and the recording from last class is posted to, so all of 2.3 is posted as an individual video that was not recorded while we were in class together. And then the lecture from last Thursday is up, which covered the rest of 2.2, all of 2.3, and then part of 2.5. So we're going to keep that pace up if we can. Let's remember where we are. We're talking about rational functions. And, special ways. Yes, there are. Yes, there are. So I got a polynomial here. It's rational, a rational function. It's got polynomials in the numerator and denominator. And the denominator polynomial function is not allowed to be 0 because it would cause division by 0. So here are this is just kind of a table of functions we're going to talk through. I'm going to walk you through domains of each and horizontal asymptotes, vertical asymptotes, and then we're going to get in and break down these problems. And I tell you what, it'll probably be easier. I don't think we're going to have any trouble, at least not yet. So we've done the first two. Vertical asymptotes occur when the denominator is 0 in the unfinished, in the reduced form. We haven't, and then if I have an x minus 4 and an x minus 4 in the numerator and denominator, we're not going to see a vertical asymptote there. We're going to see a hole, but that is at the end of this section. So don't worry too much about that yet. So let me take a look at the next problem. F of x is 6x minus 1 over 2x plus 5. What is the domain? All right, so the domain is the denominator can't be 0. So what makes the denominator 0? I don't know. Let's take the denominator, set it equal to 0, and solve. 2x plus 5 is 0, which means 2x is negative 5, which means x is negative 5 over 2. Okay, so that if I plug in x is negative 5 over 2, I'm going to cause division by 0. So that number is not allowed to be in the domain. So is that the only one that I got a problem with? Yep. So how do I skip a number? Negative infinity up to that number. Do not include union that same number, comma, infinity. Vertical asymptotes. So this is in its fully reduced form. There are no common factors in the numerator and denominator. So whatever made that denominator 0 is the vertical asymptote. And we just found it. It's right there. There's the vertical asymptote. X is equal to negative 5/2. Horizontal asymptote. The degree of the numerator is 1. The degree of the denominator is 1. So that means my horizontal asymptote is the ratio of the leading coefficients. So when n is 1 and d is 1, then the horizontal asymptote is y equals a over b. A is the leading coefficient of the numerator, so that's 6. And b is the leading coefficient of the denominator, which is a 2. 6 divided by 2 is 3. So that means I'm looking at horizontal asymptote of y equals 3. All right, so we've seen the 3 cases, or we've seen 2 of the cases now. If the numerator has a higher, if the denominator has a higher degree than the numerator, the horizontal asymptote is always y equals 0. This is the first one we've seen where the powers, the degree of the polynomial function in the numerator and the degree of the polynomial function in the denominator are the same. All right. Now I'm going to stop there. We'll go into our problems here and kind of knock some of this stuff out piece by piece, And then at the end of this, we can come back and take a look and see if we can now do all the parts of this. So first thing, observations. So up until this point, just based on the few examples that we've done, okay, we know that vertical asymptotes are related to the denominator, right? They're related to the denominator because the vertical asymptotes are the same as the solutions to the factors in the denominator unless there is an equal factor in the numerator and denominator. So I'm just going to put same as solutions. I'm going to write this out. Solutions to make the denominator 0 unless there is a matching factor in the numerator and denominator. We haven't seen a case of that yet. Don't worry about it. We're gonna see that on the very last page of these notes. How about horizontal asymptotes? I need to compare the degree of the numerator, and we're calling that n, and the degree of the denominator, which we have called d. All right. If the degree of the numerator, well, let's see if we get this right. If the degree of the numerator is less than that of the denominator, a horizontal asymptote exists at y equals 0. Okay, so cases of f of x is equal to 5 over x plus 3. Numerator has a degree 0, denominator has a degree 1. So as x goes really, really big, the denominator keeps growing, which means this fraction in its entirety goes towards 0. So that's why we end up with that y equals 0. All right, next one. If the degree of the numerator is equal to that of the denominator, a horizontal asymptote exists at the ratio of the lead coefficients of the numerator and denominator. Okay, so we saw this 2x minus 3, 5x plus 4, horizontal asymptote, the ratio of the leading coefficients. Why is that? Because as x goes off to positive infinity, my numerator is going to head toward 2, my denominator is going to head toward 5. So where is this going to end up going? 2/5. All right. And then the last thing I said, there's a hole when there is a common factor in the numerator and denominator. Let me give you an example of that. Okay, and I'm going to write this out already in factored form. So if I give you h of x is equal to x plus 2 over times x minus 3 divided by x minus 3, this means I have a hole at what? When x is 3. Okay. Now, once you determine what's the x value of the factor that matches in the numerator and denominator, then you take what you have found, this 3, and you plug it into the reduced form of your function. And what would that look like? Well, I've got x minus 3 over x minus 3. Those go away. So h of x is equal to x plus 2 times x minus 3, all divided by x minus 3. It reduces to just x plus 2. Well, that's just a line, okay? But there's a hole. And the whole is going to be made up, it's just a single point. And what do I get? 3 plus 2, which is 5. So that whole has the coordinates 3, 5. All right. So if you see the same factor in the numerator and denominator, there's going to be a whole at the x value that makes that 0. You can find the x value pretty easily. To find the y value, you need to write it in its reduced form. So actually, yeah. All right. And then last part, a blank asymptote exists when the degree of the numerator exceeds the degree of the denominator by 1. Find that by using what? Well, this is called a slant asymptote. So instead of having a horizontal asymptote, we have a slant. And you find that by using long division or synthetic division. Okay. So those are our vocabulary words. Like I said, like I say all the time in here, what matters are examples. So we will do as many of those as we can sneak into an hour of time. Okay, so what's next? Okay. I know these are looking a little different than yours. I'm actually ahead in the notes, so all the problems are listed in the notes. If you've got your guided notes out, the problems they look a little different, but they're not. It's the same exact problems. They're just formatted differently in the OneNote. So using what we've seen, find the vertical asymptote and horizontal asymptote of each function. All right. So f of x is equal to 2x minus 3 over x minus 1. Is this reduced all the way? There's no common factor between the terms of the numerator, none between the terms of the denominator. So yeah, that's as reduced as it'll get. So first, let's find our vertical asymptotes. Vertical asymptotes are going to occur when the denominator is 0. What makes the denominator 0? X minus 1 equals 0. So whenever x equals 1 appears, this is vertical asymptote. Okay. You can have multiples of these, right? You can always have a quadratic in the denominator that there's 2 places where it goes to 0. Horizontal asymptote is controlled by the degree of the numerator and denominator. Well, the degree of the numerator is 1. The degree of the denominator is 1. Is everybody comfortable with that? Why is it 1? Because I have my variable. There's no power written, so there are understood ones there. So the degree of the numerator is 1. The degree of the denominator is 1. Whenever this happens, when n equals d, then we're looking at a horizontal asymptote of the ratio of the leading coefficients. Leading coefficient for the numerator here is 2. Leading coefficient for the denominator is 1. 2 divided by 1 is 2. So that means I'm looking at a horizontal asymptote of y equals 2. All right. Next, I've got x minus 2 over 2x squared plus x minus 6. Does the denominator factor? Does it factor? Let's find out. Let's try bottoms up over here to the side, because the only thing that is going to impact the way this problem works is if the denominator can be broken down into x minus 2 times something. So let's go after the denominator first before we do anything else. So we're going to attempt to factor 2x squared plus x minus 6. So bottoms up says just pretend like this is x squared plus x minus 12. All right, so two numbers that multiply to 12, excuse me, negative 12, and add to 1. Do those exist? Absolutely. They're 1 unit apart. What are they? They're x plus 4 and x minus 3. And then remember we did bottoms up. So I come back with my, A. That goes in the denominators. So I end up with x, 4 divided by 2 is 2. And then x minus 3 over 2, I still think we should just leave it as x minus 3 over 2. If you want to write it as 2x minus 3, you can, but I don't think it's necessary. So what did I do all that work for? Why is this, what did I get out of this? Well, now I have x minus 2 over x plus 2 times x minus 3 over 2. Why is that helpful? Because my vertical asymptotes are the values of x that make the denominator 0. Right? What values make the denominator 0? Those are my vertical asymptotes. I know this looks tempting here to divide, but if you divide factors from numerator and denominator, they have to match completely. That includes signs. So let's go for that vertical asymptote first. Vertical asymptote is found by letting the denominator equal 0 and solving. Two things multiply to give me 0. One of them has to be 0. That's the fun zero product principle that we all know and love. X minus, excuse me, 3 over 2 equals 0. So I've got x is negative 2, and I've got x is 3/2. These are both vertical asymptotes for this problem. Okay. How about the horizontal asymptote? Well, go back to the original problem, and you'll see that the degree of the numerator is 1, the degree of the denominator is 2. And what happens in that case? When the degree of the numerator is less than the denominator, my horizontal asymptote is always y equals 0. Because the denominator is growing faster than the numerator. All right. So that's 2 of those. Let's go after the next one. All right. Now, does this factor? Okay. Let's try. Okay. So x squared plus 3x minus 4 over x squared minus 1. Two numbers that multiply to negative 4 but add to 3. Okay. Multiply to negative 4 but add to 3. 4 and negative 1. All right. And in the denominator, this is the difference of perfect squares. X squared minus 1. That breaks down into x plus 1 times x minus 1. All right. Now, if you got this problem and I asked you, find the domain I would want you to find the domain right now, okay? This is the non-simplified version, non-factored, or this is a factored numerator and denominator, but I haven't done any work with it, right? So I've got a problem when x is positive 1 and when x is negative 1, so those values are out of my domain. Now, this is the case where I have the same factor in the numerator and denominator, so these divide away. X minus 1 does not leave a vertical asymptote with it because this is going to correspond to a hole in the graph. Vertical asymptotes are what are the values of x that make the denominator 0 in the reduced form. So I got a vertical asymptote, and x plus 1 is 0, which is negative 1. Okay. Horizontal asymptote. If I start over, degree of the numerator is 2, degree of the denominator is 2. Whenever the degrees are equal, there's a horizontal asymptote at the ratio of leading coefficients. Both of these have a leading coefficient of 1. So that means I'm looking at a horizontal asymptote of 1. All right, questions? Now, let me see. Let's try to wrap our head around some visualization of what's happening here. I'm typing in our function from that last problem. And I have x squared plus 3x minus 4 over x squared minus 1, right? There's only one vertical asymptote here. Everybody agree to that? Vertical asymptote is, what did we say it was on the last one? Vertical asymptote was x is negative 1. So let me plug this in. I'm going to write this line. X equals negative 1. And look at that. This is a vertical asymptote, and this is what it looks like on a graph, right? My function can never be, I can never plug negative 1 in, right? So when that happens, I see behavior in that function. The function likes to get as close, it likes to snuggle up next to the asymptote, but it never actually touches it. Okay, so that's what a vertical asymptote looks like. What does a horizontal asymptote look like? Well, we said this problem had a horizontal asymptote of y is 1. So what does y equal 1 look like? Well, that's a horizontal line. So vertical asymptotes are vertical lines, x equals some number. Horizontal asymptotes are horizontal lines, y equals some number. A function is allowed to cross a horizontal asymptote because the horizontal asymptotes are really just there so that I can determine what the end behavior is for my function. What happens as x goes off to, to the millions, right? It keeps getting closer and closer to that horizontal asymptote. Crossing it is okay, though. It's going to happen sometimes. Vertical asymptotes, on the other hand, there's never going to be a case where they cross, okay? Because if they ever crossed, that means your function would cause division by 0, which is not allowed. All right. The other thing I mentioned, I'm going to name this function real quick so that I can use features. So f of x is the red x squared plus 3x minus 4 all over x squared minus 1. Now, in the notes, we said there's going to be a hole when x minus 1 equals 0, right? And it's from this division right here. So that is when x is 1. When x is 1, I'm supposed to have a hole. Do I have that on my graph? Well, let's find out. When x is 1, what is f of x? It's undefined. So when x is 1, take a look at that graph. What happens when I land directly on 1? There it is. 1, comma, undefined. And what is that value? So 1, 2.5. Okay. You won't see these holes in the graphs. You'll have to go find them. So if you graph this on a calculator or on Desmos, notice that hole's not, just sitting out there. But I can plot a point. I believe that's what it is. Okay, so it lives right there. I found the x value because of this division. When I took my original function and I broke it down into its factored forms, I had a common factor of x minus 1. When I divide that away, I have to respect the fact that what did I just do? I took x minus 1 and divided by x minus 1. X minus 1 is never allowed to be 0, right? What makes x minus 1 0? Positive 1. So what does my graph do for me, or why do I find that hole there? Because if it's not there, when x is 1, I divide by 0, and that is not allowed. So because it's not allowed, this is how it picks up. I get 1, comma, undefined. Now, if I wanted to find that value, and let's just write this up all the way. We said there's a hole when x is 1. So I then take that reduced form after I've already divided out the whole, x plus 4 over x plus 1, and I plug in the value that I found is going to cause the problem. So f at 1 is 1 plus 4 over 1 plus 1, which is 5 over 2. So that means I have a hole at the point 1, 5/2. Okay. Everybody comfortable with that? Can we see, does everybody see why holes occur, when they, maybe not so much why, but when? They occur when I have that matching factor in the numerator and the denominator, and I divide them away. Okay. Next. What's next? Number 4, or page 4, or excuse me, question 4. What are my vertical and horizontal asymptotes? Well, do I have something that factors here? Okay. What makes the denominator 0? All right. And then we'll come up here and deal with this. If you can't factor a rational function, does that mean it most likely doesn't have any holes? I would say, yeah, if it doesn't factor normally, like you may have to break it down with the quadratic equation, but if you only get imaginary answers or complex answers, then yeah, there are no holes. Okay, so vertical asymptotes occur when the denominator is 0 So what makes the denominator 0? 12x squared plus 1 equals 0. 12x squared equals negative 1. X squared equals negative 1 over 12. Take square root of both sides. X is equal to positive and negative square root of negative 1/12, which is I square root 12. I'm not going to make you go any farther than that because it's not necessary. These are complex roots. Okay. So that means no real number makes the denominator 0. Right? The only thing I can plug in for x that would make the denominator be 0 is imaginary. All right? So when that happens, there's no vertical asymptotes. Okay? How about holes? Well, if there's a hole, then that means the numerator and denominator there must be some number that makes them both 0. There's not. There's no real number that does it, so there's no vertical asymptote, and there are no holes. Okay. Horizontal asymptote, on the other hand, is fine with this. The numerator has a degree of 2. I do that every time in the notes. The denominator has a degree of 2. N and D are equal. That means y is equal to the ratio of the leading coefficients, which is 3/4. Horizontal asymptote, y equals 3/4. All right. And then lastly, x squared plus x plus 5 divided by x minus 2. Does the numerator factor? X squared plus x plus 5. There are two numbers that multiply to 5 and add to 1. Multiply to 5 and add to 1. No, I was thinking like 10 and 2 or 10 and 1/2 or something, but no, I don't think anything's going to do that. Multiply to 5 but add to 1. So it looks like the numerator does not factor here. Okay, so that means this is in its reduced form. So where are my vertical asymptotes? Got a vertical asymptote. When x minus 2 equals 0, or when x is 2. About that horizontal asymptote. Well, I got a numerator has degree 2, denominator has degree 1, and this is our first time. When n is 1 more than d, we have a slant asymptote. Okay. There's no horizontal asymptote here. There's a slant asymptote. How do I find it? I just do the math that's being asked of me. I do it with either long division or synthetic. Okay. In this case, I can do this with synthetic because I'm dividing by a linear factor with a coefficient of 1. So x minus 2 is interesting when x is 2. Coefficients are 1, 1, and 5. Bring the 1 down, multiply by 2. 2 times 1 is 2. Add 1 plus 2 is 3. 3 times 2 is 6. And 6 plus 5 is 11. Okay. Whatever's left over here is my slant asymptote. What is that? Well, I started out, this is x squared x and the constant. When after I perform synthetic division, this drops by a power. So this is x, and this is the constant. So there is my slant asymptote. Okay, and you can do this with long division, but only because I'm dividing by x minus 2. What does this look like graphically? Okay, so x squared plus x plus 5 over x minus 2. All right, so take a look at that. Okay, vertical asymptote is still hanging around. We're used to it when x is 2. So there's our vertical asymptote. Whenever you graph this on paper or do a sketch, vertical asymptotes and horizontal asymptotes typically get dotted lines. But for this case, I'm just showing you how this lines up. Now that slant asymptote was a linear equation. It was y equals x plus 3. Look at what's happening. I don't have a horizontal asymptote because as x goes to positive infinity and x goes to negative infinity, instead of just trying to fall down on one value, it continuously chases the line y equals x plus 3. And it chases it in both directions. So this is what a slant asymptote looks like. And this is how they graph. All right. Questions? Not yet? Okay. All right. Then let's go find some vertical and horizontal asymptotes. All right. Only do what's asked of you. Don't do more work than what is asked of you. For the first 3 in skill practice 2, I'm asked to identify the vertical asymptotes. Vertical asymptotes occur when the denominator equals 0, right? And the numerator and denominator don't share a matching factor. Well, they don't here, 3 over x plus 1. So when is x plus 1 equal to 0? When x is negative 1. So there's vertical asymptote for the first one. For the second one, I need to see if this factors. Okay. Does this factor? Yes, it does. X plus 7 over two numbers that multiply. What have I got? 2x squared is going to break down into 2x and an x, because that's the only way to get 2x squared. And then I need to multiply to negative 10, add to negative 1. 5 and 2 would do that for me. And 5 and 4 are 2 off. So if I make this a 2 and this a 5, I think I get it. And which one is larger than negative? So it's minus 5 plus 2. So let me write that out one more time. Why am I bothering to do this part? because if the numerator and denominator share a factor, then I don't have a vertical asymptote. Okay, but there's no x plus 7 in the numerator and denominator, so I don't share an asymptote. So I don't have any holes. These are both asymptotes. So they're going to occur when 2x plus 5 is 0. So when x is 5 halves, we're going to have a vertical asymptote. And then x is -2. So there are my vertical asymptotes. All right. How about the last one? 5x over x to the 4th plus 1. There's no holes because there's no way 5x and x to the 4th plus 1 have any common factors. So I just need to figure out, are there any values that make the denominator 0? Solve for x. So I'm going to take a 4th root and here's the tricky part of this question. I have a negative. It's under an even root. So that means my answer is somehow complex. What is it? I don't know off the top of my head, because the only thing I know for reducing complex numbers is if I have the square root of negative something, -1, I can pull an I out. I can't pull anything out here because I'm actually taking a 4th root, but my problem still results in imaginary solutions. So that means, what that means, no vertical asymptotes, just like before. Because I ended up with a negative under an even root, I'm not going to have any vertical asymptotes here. Right? I only want real numbers that solve the denominators. Next, horizontal asymptotes. Horizontals are the easy ones, I think. So all you gotta do is find your powers, find your degree. Numerator has degree 2, denominator has degree 2. And again, it's just what's the highest value of the power of x. When they're equal, what happens? I use the ratio of the leading coefficients, and that is 7/4. Next, 4x cubed plus 2 over 2x minus 1. Degree of the numerator is 3. Degree of the denominator is 1. And what happened here? The numerator is larger than the denominator. So this means there'll be no horizontal asymptote. The problem just asks, are there horizontal asymptotes? There are not. There is a slant asymptote here, and it's actually kind of a weird one, because when I go to do division of 4x cubed plus 2 over 2x minus 1, when I divide that, the result is going to be a square. So if I were to plot this or show you what this looks like on a graph, it's going to have a weird look, because my slant asymptote is not a straight line. It's actually a quadratic. Divide 2x minus 1. Okay. How weird does that look? Okay. That looks really weird, doesn't it? But what's it doing? The function is chasing a parabola, because when you do this long division out, you're going to end up with a parabola, and you're going to see as x goes negative infinity, it's chasing this side. As x goes to positive infinity, it's chasing on that side. So it's a weird case. And if you'll notice, we were not asked to find slant asymptotes, which is why I didn't do any more work than was asked of me. Last one, 5 over 4x squared plus 9. Degree of the numerator is 0. Degree of the denominator is 2. When n is less than d, I always have that horizontal asymptote at y equals 0. Okay. Remember that n is the degree of the numerator, d is the degree of the denominator. Don't get confused, and because there was a, just a little half second there where I said, oh, 5, that's degree 5. No, it's degree 0 because there's x is not there. So I've got x to the 0. All right. Next is determine where a graph crosses a horizontal asymptote. So we said this was allowed before, right? So got h of x, and I want to know what is the point where the graph of h of x crosses the horizontal asymptote. Horizontal asymptotes, again, are really just trying to talk about what does my function do as x goes off to positive infinity and negative infinity. So first thing I got to do is find horizontal asymptotes. Are there some? For h of x, I'm looking at a numerator that has a degree 2 and a denominator that has a degree 2. When n equals d, my horizontal asymptote is the ratio of the leading coefficients. Leading coefficients are 8 and 2. 8 divided by 2 is 4. So what I want to know is when does h of x equal 4? That's what this is asking. Well, h of x is the quadratic, or the rational function 8x squared plus 9x minus 5 divided by 2x squared plus 1 equals 4. And then I solved that. All right. How in the world do you solve that problem? Okay. Well, right off the bat, I have a rational function on the left and a constant on the right. I'm going to help myself out, make this into a proportion, because I know if two fractions are the same, their cross products must be the same. So if this rational function equals 4, then 8x squared plus 9x minus 5 times 1 must equal 4 times 2x squared plus 1. This side doesn't change. And then on the right, it's 8x squared plus 4. Okay. Combine like terms. Subtract 8x squared from both sides. I'm going to try to get, it's a square, so I'm going to get everything on the same side. Get that plus 4 to go away by doing minus 4. 8x squared minus 8x squared is 0. 9x minus 0 is 9x. Negative 5 minus 4 more is negative 9. 8x squared minus 8x squared is 0. 4 minus 4 is 0. So I have 9x equals 9. So it was quadratic, but that subtracting there caused my square term to zero out. So now this is linear. I know how to solve a linear equation. Everything with an x on one side, everything without on the other. Solve for x. And I find that x equals 1. Okay. Now, remember the question we're asking. We're asking, when does h of x equal 4? Okay. Well, it does it when x is 1. Let's check to make sure that's right. Make sure we didn't make a mistake. So I'm going to plug 1 into h of x, and I better get 4. That's 8 times 1 squared plus 9 times 1 minus 5 over 2x squared plus 1. It's always nice when the variable is 1, because all that's left are just all your original coefficients. 8 plus 9 minus 5 over 2 plus 1. 8 and 9, 17. 17 minus 5 is 12. 2 plus 1 is 3. So that equals 4. So where do I cross? At the point 1, 4. So I've done one. Now you do one. So take a minute, knock out the next one. All right, so gotta find when it's across horizontal asymptote. Let's find the horizontal asymptote. Numerator has degree 2, denominator has degree 2, which means I'm looking at a horizontal asymptote, 3 over 1, which is 3. So then when, just like before, is g of x equal to 3, right? You're given, in this one, you're given the y value, and they're asking you what value of x makes this happen. G of x is 3x squared plus 4x minus 3 over x squared plus 3. I want to know, when does that equal 3? So I'm going to cross multiply. X squared plus 3. No, bad Larry. 3x squared plus 4x minus 3 times 1 equals 3 times x squared plus 3. Distribute, multiply. all that fun stuff. 3x squared plus 4x minus 3 is equal to 3x squared plus 9. Same thing is going to happen here as it did last time, right? My leading term goes away. Minus 9, which causes my equation to go from quadratic to linear. 3x squared minus 3x squared is 0. 4x plus nothing is 4x. Negative 3 minus 9 more, negative 12. Solve this. Add 12 to both sides. Get x totally by itself. X is 3. And now, to check, I'm going to find g at 3 is 3 times 3 squared plus 4 times 3 minus 3 over 3 squared plus 3. What does that equal? 3 times 3 squared is 27. 4 times 3 is 12. In the denominator, 3 squared is 9. Uh, 27 and 12 is 39. 39 minus 3 is 36. 9 plus 3 is 12. 36 divided by 12 is 3. So I cross at 3, 3. All right. Questions? No? All right. Then let's go after those funny asymptotes. All right, so I got 2 more here. Determine the asymptotes. That's fine. We can determine those asymptotes without any trouble. I want to check out vertical asymptotes first, but I have to make sure that I see x minus 2 is in the denominator, so that corresponds to x equals 2. Is there a vertical asymptote at x equals 2? There is, as long as the numerator does not simplify or does not factor into something with an x minus 2. So let's find out, what does that numerator factor into if it factors into anything. 2x squared minus 5x minus 3. We can do bottoms up, or I think we can do this one in our heads. 2x and x, and then I need to multiply to negative 3. So that's going to be negative 1 and 3, or negative 3 and 1. The tough part here is that middle coefficient b. I need to multiply to negative 5x. Well, if I multiply the 2x by negative 3, and then I multiply the x by 1, do I get it? 2x squared minus 6x plus 1x, or minus 5x, times negative 3. Yeah, that factors. All right, so my function looks like this. 2x plus 1 times x minus 3 divided by x minus 2. Now, I know where the vertical asymptote is. Take the numerator, because there's no match. So take the numerator, set it equals 0, and solve. And there's a vertical asymptote at 2. And then horizontal asymptote. degree of the numerator is 2, degree of the denominator is 1. So that's no horizontal asymptote. Okay. Instead, we have a slant, right? When the degree of the numerator is 1 more than the degree of the denominator, or just when the numerator is larger than the denominator in degree terms, there's a slant asymptote. Why is that? Because look at the original problem. I have something with x squared in it divided by something with x in it. There's still math to be done here. So let's use our knowledge of synthetic division to help. X minus 2 is what I'm dividing by. I'm dividing into 2x squared minus 5x minus 3. If you're wondering, does it matter if the coefficient here, if the remainder here is 0 or not, it does not matter. All we want are all the coefficients to make up the linear equation that we're going to end up with. Drop the 2. 2 times 2 is 4. Negative 5 plus 4 is negative 1. 2 times negative 1 is negative 2. Negative 3 plus negative 2 is negative 5. So I have a slant asymptote at y is equal to, this was squared, this was to the first power, this was the constant. So now that 2 goes to the first power, that negative 1 is the constant. All right. Last one, 2x squared minus 9. That is not going to factor, so I'm not even going to bother. It's the difference of perfect squares, but it's not going to break down to something with x plus 1. So vertical asymptote, take the denominator, set it equal to 0, and solve. If you want to check to make sure that it doesn't, that the numerator and denominator don't have the same power, plug negative. So I found that negative 1 makes this go to 0. Negative 1 is not going to make that numerator go to 0. So you don't have to worry about 2x squared minus 9 breaking into an x plus 1. So I got a vertical asymptote. How about that horizontal? Numerator has degree 2, denominator has degree 1. So that means what? I have no horizontal again, but I do have a slant. And I find it the exact same way. I'm dividing by x plus 1, so negative 1 goes into the box. I have 2x squared. I don't have a term with just x, so that gets a 0 for a placeholder. Draw our lines. Bring the 2 down. 2 times negative 1 is negative 2. 0 plus negative 2 is negative 2. Could you stop there? Absolutely. But since you're doing the problem, you might as well do it. So what does that 2 and negative 2 correspond to? Well, that's 2x, and that's negative 2. All right. Horizontal asymptotes, vertical asymptotes. Now we have talked through slants. Last thing, and I know we only have a few minutes, but let's talk about that hole in the graph. Let me show you what it looks like. So here it is again. This is similar to the problem we did before. The numerator and denominator have both been factored, and we see a common factor of x plus 3 in the numerator and denominator. Now, those can divide away, right? So if I reduce this function, what does it look like? It looks like x minus 6 divided by x. Okay? So it's x minus 6 divided by x, but it has a whole when x is negative 3. That whole is an indication that there has been a division in the original problem, a division with the same factor in the numerator and denominator. What are the coordinates of that whole? Let's find out. So when x is negative 3, I plug that into my reduced form, and I find negative 3 minus 6 more divided by negative 3. Negative 3 minus 6 is negative 9. Negative 9 divided by negative 3 is positive 3. So I should see a hole at the point, negative 3, 3. Is that where it is? Yep. 5, 4, 3, 1, 2, 3. So there's the hole. The y coordinate of the hole is found by plugging in the x coordinate of the hole into the reduced form. And this is what I mean when I say reduced form. All right, so any holes in this graph? Well, the numerator is 2x squared minus 3x minus 2. So two numbers that multiply to negative 2. It's going to be 1 and 2. It's just a matter of which goes where. Okay. And I need to add to negative 3, which means 2x times negative 2 is negative 4. 1 times x is 1. Negative 4 plus 1 is negative 3. Denominator is difference of perfect squares. So it breaks down into x plus 2 times x minus 2. I can see that I'm going to have a hole when x is 2. Now, reduce this. 2x plus 1 over x plus 2. So what is the y coordinate of the hole? Take the value of x that causes the hole, plug it into the reduced form. 2 squared is 2 times 2 is 4 plus 1 is 5. 2 plus 2 is 4. So I've got a hole at 2, 5 fourths. All right. And I will make a video for the last, there's only 4 pages left in 2.5. So I will make a video and post that so you'll have the completed lecture. This yes, I'll have this, I'll get this posted along with the rest of this lecture. So then you'll have all of chapter 2 done. All right. Any other questions? Anybody got anything? No? All right. Y'all have a great night.